Okay, this is the last set of notes for Unit 1 for Honors Math 3, and we are dealing with piecewise functions. Now, what we did in Objective 5 was leading us to this, okay? And previous objectives were also getting us ready for it as well. Okay, so 3 sample problems here, and then I actually want to do probably at least 2, maybe 3 from the assignment with you as well. Okay, so first couple problems, we're giving you the equation and we're having you graph it, and then the third problem we're giving you the graph and we're having you write the equation. Okay, so problem number 1 here. Okay, so what is a piecewise function? Piecewise function is made up of 2 or more pieces of graph, and they might be connected, they might not be connected, it just kind of depends. But they make up one function. Okay. Now, how do I know how many pieces? Well, for example, take a look here. The first problem, we got f of x equals, there's a top line, and then there's a middle line, and then there's a bottom line. So this is a 3-piece one. Same thing with number 2, there's 3 pieces right there. Okay. Now, before we actually graph, let's just evaluate, because we need to be able to evaluate piecewise functions as well. Okay, so if I want to do f of 3, so f of 3, well, how do I know where to plug it in? Well, is 3 less than negative 2? No, so it's not the top rule. Is 3 between negative 2? Yes, you can touch the negative 2 and 3. No, because 3 is equal to 3. So what about the bottom rule? X is greater than or equal to 3. So yes, this one is the bottom rule. And so if I do f of 3, the bottom rule says no matter what you input, you get negative 3 coming out. Okay, now if I do negative 2, going to kind of go through the same process here. Is it the top rule? Well, it says x less than negative 2, but negative 2 is not less than negative 2. So is it the middle? Yep, look, it's the equal sign is there with the negative 2. So this is the middle rule, and so f of negative 2 is 7 minus negative 2 squared. Now, negative 2 squared is 4, so this is 7 minus 4, so f of negative 2 is 3. F of negative 10, okay, well, where is negative 10? Is negative 10 less than negative 2? Yes, so it's the top rule. So f of negative 10, we've got negative 10 plus 4, which is negative 6. Absolute value of negative 6 is positive 6. So I have negative 1/2 times positive 6 plus 3. So negative 1/2 times positive 6 is negative 3 plus 3 is 0. Okay, finally, f of 10. And I think it's pretty easy to see that that is the bottom rule. And so f of 10 is negative 3. Okay, so we do need to just be able to evaluate functions. And you got to pay attention to the domain restrictions there on the different rules as to what's going on. Okay, so let's go ahead and let's start to sketch it. Now, I have found for some people, at least at the beginning, it might be kind of helpful to put in some boundary markers. Ultimately, we try to stay away from these and get away from them. Now, what do I mean by boundary markers? You got negative 2 is mentioned in 2 different rules, the top rule and the middle rule. So it's kind of a boundary marker. So negative 2, it's not an asymptote of any sort, but kind of a boundary marker. Okay, I guess you could actually do that, but we're trying to get away from this, but this is our first one we've ever done, so we'll go ahead and put it in there, because when you dot it like that, it looks like it's a vertical asymptote. Another boundary marker is at 3, because you got x is less than 3 in the middle rule, and x is greater than or equal to 3 is out to the right. So x is 3, and if you really need to right now, I suppose you can get x equals 3. It looks like I put 3 at the wrong place originally on the top. So, okay, so now, remember I said it's going to be 3 pieces? So we have a piece out here to the left. We have a piece here in the middle, and we have a piece out here to the right. Okay, I'm going to erase those. Okay, and again, maybe until we're getting used to it, maybe we're doing some sort of color coding. Okay, this first piece, now we need to recognize that we look and we go, oh, hey, that's a linear absolute value. The vertex is at -4, 3, and it's opening down, V-shape opening down. Okay, is -4 in that domain? Is -4 less than -2? Yes, so let's plot that point. -4, 2. Okay, and the a value is -1/2. So if I go down 1, and if I go to the right 2, and if I go to the other side 2, those are my lattice points that are on the curve. Now, one of those is on the boundary, and boundary points are sometimes hollow. Okay, sometimes they're solid, sometimes they're hollow. If it's not a boundary point, it's always going to be a solid point. So I think coming from the vertex and going out to the left is definitely going to be safe. But let's take a look. This boundary point, x less than -2, for the left-hand rule is you can't touch the -2. So it needs to be a hollow dot, and there's the left-hand piece. Okay, the middle piece, and by the way, you don't have to do them in order, left piece, middle piece, right piece. You don't have to do them in that order. You can do them in any order that you want. The middle piece is a parabola opening down, because the a value is -1. And the vertex is 0, 7, is 0 in those boundaries for the domain restriction. Is 0 greater than or equal to -2 but less than 3? Yes. So 0, 7, 1, 2, 3, 4, 5, 6, 7. There's my vertex. If I do my a value, -1, so if I go 1 point to either side, I would go down 1. And none of those are boundary points, so they're all going to be solid points. Okay. Now, boundary points are absolutely critical. Absolutely critical. We have to know what's going on at the boundary. So I'm going to input a -2, and I'm going to input a 3 into the middle rule. So if I input a -2, 7 minus a -2 squared. In fact, we already did that, because that was this one right here. And so we get 3. If I input a 3, I get 7 minus 3 squared, which is -2. Okay, now, can I touch at x equals -2? Well, it says greater than or equal to, x is greater than or equal to -2. Read from the center out. So that one's solid. So -2, 3 is a solid point. On the other hand, the other boundary, x less than 3, you don't get to touch at 3 because it's just less than 3, so it's a hollow dot, so 3, negative 2, nice hollow dot. Okay, those are the boundary points. We got the vertex, a couple of lattice points here, and then we get the boundary points, so let's sketch that parabola. Okay, there's the middle piece. Okay, so the left-hand piece and the middle piece did not connect on this one. Sometimes they connect, sometimes they don't connect. Finally, the last piece here, we've got f of x equals negative 3. So y equals negative 3. That's a horizontal line. Y equals negative 3. Okay, and it's for the domain values of 3 and to the right forever. So boundary points, if I input a 3, do I get to touch? Yes, I get to touch, and then it's just a horizontal line staying at that elevation. So there's the graph of the function. Okay, now notice none of the pieces connected. That's fine. What is the domain for this function? Well, does it go further to the left? Yes. Does it go further to the right? Yes. I know there's a hollow dot at negative 2, but isn't there a solid dot also at negative 2? So negative 2 is in the domain. At positive 3, I know there's a hollow dot, but isn't there also a solid dot at positive 3? Yeah. So the domain is all real numbers. The range. Does it go down forever? Okay, now be careful. You see that arrow out to the left? I know it's going to the left, but it's also going down. Does it go down forever? Yes, it does. So it goes all the way down to negative infinity. So even some of these elevations that we're not hitting, that down arrow tells us we're going down to negative infinity. Does it go up forever? No, there is a highest point. The highest point is 4, 6, 7. And yes, it touches it, and it hits all the elevations in between as well. Okay, now, that one just took some time. Let's do the second one. We'll pick up the pace here a little bit. Okay, so g of 0, again, this is a 3-piecewise function. So g of 0 is 0 less than negative 2. Is 0 in here? Yep, it's the middle rule. So negative 1/2 times 0 minus 1, negative 1. G of negative 4, that's the top rule. Negative 4 is less than negative 2. So negative 4 plus 3 is negative 1. Squared is 1 times 2 minus 2, that's 0. G of 2, that's the middle rule again. Negative 1/2 times 2. Negative 1/2 times 2 is negative 1 minus 1 is negative 2. And g of 8, well, that doesn't fit it anywhere. It's not in the domain. Now, when you put a 0 with a slash through it, it is not 0. It means the empty set or does not exist or undefined. So g of 8 is undefined, and that is not a 0. Okay, okay, so first piece here on the left, we can see that that is a parabola, and it's opening up. And my vertex is negative 3, negative 2. And is negative 3 in my domain? Yes. So negative 3, negative 2. And now if I went 1 point to either side, my a value is a positive 2. So up to 1 point to either side and up 2. But now I'm on my boundary. Negative 2 is one of the boundaries. So is negative 2, can I touch at negative 2? Can I touch at -2? No, I can't touch at -2. It's hollow. Okay, so I need to hollow out that dot at -2. Okay, so hollow out the dot. Okay, and sketching the parabola. And it's going left forever also. Okay, it's going up, but it's also going left forever. Okay, middle rule. Middle rule is a line. Y equals mx plus b. Okay, and now boundary points are so critical for line. In fact, the boundary points are more important than the highlighted point. I mean, the highlighted point, y equals mx plus b, it is -1, so that's pretty easy to do. But -2 and +2, so -1/2 times -2, that is 1, -1 is 0, and if I input a 2, -1/2 times 2 is -1, -1 is -2. Okay, can I touch the boundary points? Yes, I can touch the boundary points on either side. So -2, 0 I can touch, 2, -2 I can touch. So 2, -2, and then -2, 0. Now I go to -2, 0, and there's a hollow dot there. Sometimes a hollow dot gets filled in, but a solid dot never gets hollowed out. Okay, sometimes a hollow dot will get filled in, so those two pieces are connected at x equals -2, but we never hollow out a dot that's already solid. Okay, last piece, we've got linear absolute value function. The vertex is 4, 2, and it's opening down. Okay, is 4 in the domain? Yes, it is. Okay, and so let's go ahead and plot that. So 4, 2, now it does have boundary points at 2 and 7. So let's actually plug those in. Okay, so 2 and 7. We could try going down 2 and over 1. It doesn't hurt to do those. But x and y. So if I input a 2, 2 minus 4 is -2, absolute value of it is 2, times -2 is -4, plus 2 is -2. Okay, and so and then if I input a 7, 7 minus 4, 7 minus 4 is 3, -2 times absolute, so -2 times 3 is -6, plus 2 is -4. So 7, 2, 4, 6, 7, -4. And do I get to touch? I get to touch there. Okay, now at -2, 2 says I can't touch the 2, but there's a solid dot there already. Remember I talked to you about this. I said you might fill in a hollow dot, but you never hollow out a dot that's solid. It's already solid. Okay, so that's fine. Do I have any arrows? No, it ends at 7. Okay, and so there's my function. Okay, so this one, all three pieces are connected. Sometimes the pieces connect, sometimes they don't. Okay, let's do the domain and range. So the domain looks like it goes forever left, so -infinity to 6, and nothing gets left out along the way. And the range looks like the lowest elevation is -4 then it goes up forever. Okay, last one. Let's open it. So if I give you the equation, or excuse me, if I give you the graph when we write the equation. Now, generally, the top piece is for the piece on the left, and the bottom piece is for the piece on the right. And if there's a middle piece, then it goes in the middle. You can do in whichever order you want, but I'm just going to go from left to right, top piece. Okay, so first off, what's this? Isn't that, let's see, 1, 2, 3, 4, 4, negative 4, 4, vertex, negative 4, 4. And the A value, it's linear, so aren't we going down 3 and over 2? Down 3 and over 2. So y equals, the y is already there, y equals negative 3 halves absolute x plus 4 plus 4. So there's my equation. Okay. Now that's for the domain values of, looks like to the left of negative 2. So x is less than negative 2. Now I'm not doing the equal sign yet. I'm gonna come back to the equal sign here in just a little bit. Middle piece of the parabola. Okay, middle piece of the parabola, and the vertex is at 1, negative 2. So maybe we do a little bit of scratch paper. Y equals a x minus 1 quantity squared minus 2. Okay, and then we got to plug in some point. What's a point that we know is on the curve? Well, negative 2, 1. So if we plug that in, 1 equals a times negative 2 minus 1 quantity squared minus 2. And so I'm going to add the 2 to the other side. 3 equals a times, okay, negative 3 squared is 9. So a is 1/3, because 3 over 9 is 1/3. So I'm going to replace the a with 1/3. So we've got 1/3 x minus 1 quantity squared minus 2. Okay, and that looks like it's for the domain values between negative 2, so negative 2 on the left, and 3 on the right, and x is in the middle, and alligators always eat to the right, because that's the polite way, that's the good notation way, the good math grammar way. Okay, now on the right hand side it's pretty obvious to see that, because the pieces are not connecting, that should be equal there at the 3. Finally, last piece here. Last piece is just a line, okay, and what's the slope? We can count the slope. Slope is down to over 1 down, so the slope is negative 2, and the point, well, all we got to do is just pick a point. What's a point that you want to put on there? To me, I think I want to plug in the point to 5, 1. So y minus 1 equals negative 2 times x minus 5. We want it in y equals form, so y equals negative 2 times x minus 5 plus 1. Now, it's fine like this. Now, don't do the y equals. The y equals is already there. Negative 2 x minus 5 plus 1. And that's for the domain values x greater than 3. Now, somebody else might be saying, well, what if I didn't choose the 5, 1? What if I chose instead the 4, 3? Well, then, negative 2 times x minus 4 plus 3 is really the same thing as that. as long as you clean it up, okay? And so negative 2x plus 8 plus 3 is negative 2x plus 11. And then if you look at this one over here, get negative 2x plus 10 plus 1, and amazingly enough, we get negative 2 plus 11. So it works either way there. Okay, now there's one last thing we have to do, because where the two pieces right here connected at negative 2, we have to include the equal sign at one place. Now, good math grammar says that you only invite it to the party one time. So it doesn't really matter whether we invite it for the left-hand piece or the middle piece, but you only do it one place. Okay, so you don't invite it to the party twice. For me, I tend to invite it to the party as soon as I see that that's happening, so I would probably put it right there. But if somebody left it off on the top piece and put it with the middle piece, that would also be correct. Okay, at this point, the notes are actually done, but I am going to do at least 2 or 3 of the problems together. So if you want to stop watching the notes right now, you could stop. But if you want to watch me do 2 or 3 of the problems from the assignment, then just keep on watching. Okay, let's do a couple of these problems real quickly. So for example number 2 here, g of 0, is 0 less than negative 1? No. Is 0 greater than negative 1? Yes. So at the bottom rule, 2 to the 0 plus 1, 2 to the first, minus 3, negative 1. G of negative 2. Is negative 2 less than or equal to negative? Yep, so top rule. Negative 2 plus 3 is 1. Absolute value of that is 1. Negative 2 times that is negative 2 plus 4 is 2. G of 2. 2 is greater than negative 1, so it's the bottom rule. 2 to the 2 plus 1, 2 to the third, 8, minus 3 is 5. G of 1, that goes the bottom rule. 1 is greater than negative 1. 2 to the first, 2 to the 1 plus 1, 2 to the second, 4 minus 3 is 1. G of negative 1, that goes to the top rule because that's where it's included. Negative 1 plus 3 is 2. Absolute value of that is 2. Negative 2 times 2 is negative 4. 4 minus 4 is 0. Okay. Okay, let's try bottom 2 here. So, like for example, number 7, x plus 3 quantity squared for x less than negative 2. The vertex, it's a parabola, the vertex is negative 3, 0, and negative 3 is in that domain. So negative 3, 0. And boundary point, negative 2, and I can't touch it. So if I go 1 point to either side, if I go to 1 point to the right, I'm on the boundary point. I can't touch it. So that is hollow dot there. And then solid dot right there. So there's that piece. Okay, piece on the right. Absolute value, V shape, opening up, vertex is at 0, negative 1, okay, slope is up 1 over 1, okay, 0, negative 1, 0, yes, that's in the, vertex is in the domain, 0, negative 1, and then up 1 over 1, and boundary point is negative 2, but I can't touch that one either. So they kind of connect, but they neither one of them has negative 2 in the domain. And then it goes to the right forever. Okay, so doing something like that. Okay, so domain is all reals except for negative 2. So negative infinity, negative 2 union, negative 2 to infinity. The range, lowest elevation is negative 1, and it goes up forever, and it does hit elevation 1. So -1 to infinity. Okay. Moving on, back page. We're going to take a look at something from the back page here. Number 16. So if this is our function, and really 16 and 17, both of these, I do want you to go ahead and write the equation. Okay, this is going to be a piecewise function. And the one on the right will also be a piecewise function. Actually, I guess that one's going to be g of x. G of x. Okay, so we're honors math 3. Write the equation. For the interval -6 to 0, state what type of function is. It's a parabola. It's a quadratic parabola. For the interval 0 to infinity, what kind of function is it? It's linear. It's a line. Write the equation. Okay, we're not going to do that one. We're going to write the whole equation. So the parabola, the vertex is -2, 2. And let's do the line. The line is, the slope is 1. It's y equals 1x, y equals x. For all they connect, they're touching. I'm just going to go ahead and say that it's greater than or equal to 0 right there. Okay, parabola, we need the a value. It's obviously opening down. We know how to solve for the a value. The a value is -1/2. You can plug it in and double check. X plus 2, quantity squared plus 2. And that's for the x's, let's see, what is that? 1, 2, 3, 4, 5, -6 to 0. So -6 less than or equal to x less than 0. So I needed to include it at 0, one place or the other. I included it on the bottom. Okay. Use the graph from number 16. So let's go ahead and do B, and then we'll be done. So opposite of f of x. So this is reflection on the x-axis. Reflect x-axis. So there's the original. Pick out some points, have them reflect on the x-axis. Of course, 0, 0 doesn't reflect anywhere. It's still 0, 0. I pick out some other points, doing something like this, and let's see, -6. 2, 4, 2, 4, 6. And there's opposite f of x. Okay, go do the assignment. Don't forget that you're omitting problem number 19.